بسم الله الرحمن الرحيم. Linear wave. Break waves up to 6 meters high, 200 feet, that rise up from calm seas to destroy ships, do exit, researchers argue. Waves better Oregon's southern coast. Image from USGS. هنا بيبين تأثير الأمواج على الشواطئ. الكونتنت: introductions, elementary progressive wave theory, small amplitude wave theory, SWL, still water level. We will discuss about wave celerity, length and period, sinusoidal wave profile, some useful functions, local fluid velocities and accelerations, water particle displacements. Introduction. Waves are the major factors in determining the geometry and composition of beaches and significantly influence the planning and the design of harbors, waterways, shore protection measures, coastal structures, and other coastal works. Surface waves generally derive their energy from the winds. Very important. Significant amount of this wave energy is finally dissipated in the near shore region and on the beaches. Dissipation energy for waves is very important to put in our minds. Here we talk about linear wave. Linear wave. For this reason, we will study elementary progressive wave theory due to linear wave, small amplitude wave theory, SWL means still water level. We will note that there is what I mean symmetry between crest and the trough. H equal to A. H is the height of wave, the distance between crest and the trough, and the length. Length L, it's a distance between two crest or two trough. Eta, it's height of wave from SWL, our still water level, at any point of wave. We take X and Z, Z as a vertical, X as a horizontal. In this case, bottom for depth D, Z equals minus D. Eta at any point equals A cosine 2 by X over L ناقص 2 by T over T. For given origin, X0 wave profile is shown for T, 3T by 4, 7T by 4, 11T by 4. Eta equals 0 at H over 2 or 0.5 H at wave crest and at wave length trough, but at wave trough is minus H over 2. This figure definitions of terms elementary sinusoidal progressive waves because it's linear wave. Wave celerity, length and period. This is velocity. C equal L over T. C equal G L over 2 pi tanh 10 by D over L. All of this under root 0.5. C equal G T over 2 by tanh 10 by D over L. Question 3. L GT square over 2 pi multiply tanh 10 by D over L. This is question for A. For B, L is equal GT square over 2 pi multiply tanh 4 pi square over T square multiply D over G. All of this under square root 0.5. The difference between A and B is about 5%. Question 4B made it by accurate at 1952. Table 1 put classifications if deep water or transitional or shallow water. In another column D over L, it named by D over L, and third column, and fourth column tanh, it named by D over L. For deep water, the particle is circle. Particle of wave is circle, move in circle direction. For this reason, D over L bigger than half, 1 over 2, 0.5, 0.5. For by D over L, it's bigger than pi. Tanh by D over L, it's equal, approximately equal 1. For transitional and shallow, it's ellipse. Particle movement for particle move in ellipse direction, ellipse shape, not circle. For this reason, transition D over L from 1 over 2.5 to 1 over 2. 2 by D over L from 0.25 to pi. Tanh equal tanh. Shallow water less than 1 over 2.5. D over L. It's less than that. By D over L is less than 1 over 4. Tanh by D over L approximately equal 2 by D over L. That's clear. Figure 2, clear. Water particle in wave. For deep water, it's like circle, it's clear. For wave in transitional or in low depths, it's in ellipse. That's clear. Wave celerity, length and period for in deep water, it's special. C equal C naught in this case. Equal GL naught على 2 باي over 2 باي under root 5.5 equal L naught over T. For question 6, GT over 2 باي. C naught equal GT over 2 باي. In metric system, it's about 9.8 T over 2 باي equal finally 1.56 T meter per second. For English, C naught equal 5.12 T foot per second. L naught the same, it's about 1.56 T square in by meter. L naught equal 5.12 T square by foot. In shallow water, C equal GD after under root 0.05. 0.5. Sinusoidal wave profile at any point eta equal a cosine 2 by x over L. That's 2 by t over t, or a, because it's linear wave, a equal h over 2. Some useful function c over c naught equal L over L naught equal tangent 2 by d over L. d over L naught بتساوي d equal d over L equal tangent 2 by d over L. Local fluid velocities and accelerations. We notice that it's a longer equation. For this reason, we try to short this long for equation. We put 2 by x over L minus 2 by t over t in one term equal theta. We put this to short equation. For u, we can use horizontal local fluid velocities, w vertical local fluid velocities, ex horizontal local fluid acceleration, vertical local fluid acceleration, az. We notice that local fluid velocities and accelerations in the same directions for velocity and acceleration. We notice that the particle movement for deep water is like circle, in shallow water or transitional it's ellipse, like that. This table for wave function d over L naught d over L 2 by d over L, tanh 2 by d over L, sinish 2 by d over L, cosinish 2 by d over L, kg and so on. Or ks, and here we tell ks. In shallow or transitionals, we have ellipse. We shortly after all this propaganda, we arrive at equations due to ellipse. Xi square over a square plus big xi square over b square equal 1. Xi and the big xi we can see in these words or these equations, from equations 18 to equations 20. We arrive finally that xi square over a square, that big xi square over b square equal 1. Where a and b, a equal h divide 2 multiply cosine 2 by z plus d over L, sinish 2 by d over L. B equal h divide 2 multiply sinish 2 by z plus d over L over sinish 2 by d over L. Question 22 and 23. For deep water, as a question, E equal B, because it's circle, equal h over 2 multiply E under 2 by d over L. For d over L more bigger than 0.05, half. In shallow and transitionals, A equal h over 2 multiply L over 2 by d, 2 by d. B equal h over 2 multiply z plus d over d. This for d over L less than 1 under 25. These tables put all the equations that we need in our relation for shallow water and transitional and deep, for wave profile, wave celerity, wavelengths, group velocities, in horizontal and vertical velocities, accelerations in horizontal and vertical, wave particle displacement horizontal and vertical, and subsurface pressures also. For subsurface pressures, P dash the total or absolute pressures through G cosinus 2 by D multiply Z plus D over L over cosinus 2 by D over L. All this multiply H over 2. All this multiply cosine 2 by X over L minus 2 by T over T. All this group minus rho G V Z plus PA. Where P dash, the total or absolute pressure we tell you. PA, the atmospheric pressure. Rho W over G, mass density of water. In salt pressure, rho equal 1025 kilogram per cubic meter equal 2 slug over foot cubic feet. For pure water, rho equal 1000 kilogram per metric meter equal 1.94 slug over cubic feet. The pressure is usually taken as the gauge pressure. P equal P dash minus PA. We had taken that in fluid mechanics. Equal rho G cosine 2 by multiply Z plus D over L cosinus 2 by D over L. All that H over 2 multiply cosine 2 by X over L ناقص 2 by T over T. All this group minus rho G V Z. We arrived at eta equal H over 2 cosine 2 by X over L ناقص 2 by T over T equal eta. We can put this in our equations. We arrived at P equal rho G في eta KZ minus Z, where KZ equal K 1 over cosine 2 by G over L. From equation, we arrive from equation 30, we arrive that eta equal N في P plus rho في G في Z over rho في G في K Z. Okay. Wave energy and power. في kinetic energy, there is a kinetic energy and the potential energy. Everyone equal rho في G في H square over rho في G في H square multiply L over 16 E equal EK plus EP total rho في G في H square rho في G في H square L over 8. Wave energy flux is the rate at which energy is transmitted in the direction of the wave propagation across the vertical plane perpendicular to the direction of the wave advanced and extending down the entire depths. The average wave energy flux P dash equal E dash in C equal E dash CG. There is a type for deep water and shallow water. For deep water equal P naught dash equal 1 over 2 multiply E naught dash C naught for deep water. For P dash for shallow water E dash CG equal E dash C. Let's try equal between this and this. يبقى E dash node N node C node equal E dash N C. N node small equal 1 over 2. That's lead to 1 over 2 E node dash C node equal E dash N C. That's final equation 38.